The small intestine is by far the most important organ of the digestive system. I mean, that's what I believe. That's what I think. The small intestine, in its whole function, is really just about absorption. While the stomach secreted a lot of substances, the small intestine takes that slurry and absorbs it into the hepatic portal system, which then leads to the liver. The small intestine has three areas: the duodenum, the jejunum, and the ileum. These are all connected to a mesentery that suspends them in a position, a coiled position. If we do the fetal pig dissection, you see a very large glob of intestines that you can remove, but by cutting the mesentery, you could spread the intestine out fully. Each part of the intestine, duodenum, jejunum, and ileum, has a very different histology. Although they all perform absorption, they do that in very distinct ways. The small intestine aims to expand its surface area to enhance nutrient absorption. A cell, or anything, with more surface area relative to its volume can exchange more with the environment around it. And the first way that the small intestine achieves this is through these large folds here, kind of like a rippled rug. These are called circular folds, but have a much more beautiful name of plicae circulaires. These circular folds are macroscopic features able to be seen with the naked eye. Each circular fold has these smaller finger-like projections that stick off of it, called villi, and on the villi are even smaller projections called microvilli. The microvilli are so small that they form this dense forest along the outside of each villus. And you can kind of see it over here, the dense forest kind of looks like eyeliner lining the outside of our villus here. This area is called the brush border, and it's where many enzymes remain so that they can do chemical digestion on the slurry. This multi-layered structure, all of it, increases the surface area of the small intestine. If the small intestine becomes inflamed, as seen in the conditions like Crohn's or celiac disease, the plicae circulars swell, fuse, and disappear. This reduces the surface area and consequently reduces nutrient absorption. Over time, this can lead to malabsorption and nutrient deficiencies as food moves too quickly through the small intestine for proper absorption. Each villus, which is the singular for villi, contains an artery, a vein, and a lymphatic vessel. Small substances are absorbed into the vein, small like carbohydrates, possibly fatty acids, while larger substances like fats and proteins are absorbed into the lymphatic vessel. The microvilli on the individual columnar cells that form the brush border, they host numerous enzymes like lipase and amylase that are made by the pancreas. These enzymes perform chemical digestion on the products that are in the slurry. The small intestine, like the stomach, is lined with simple columnar epithelial cells, and it contains mucus cells for lubrication. And this is what you get when you use an open resource like the one I use for my pictures. The lining on this villus does not show you those scattered mucus cells that are always found in the mucosa of all of the digestive organs. The most superior part of the small intestine is called the duodenum, and it connects to the stomach, separated by the pyloric sphincter. The duodenum also receives input from accessory organs like the pancreas, the liver, and the gallbladder. The pancreas is spewing really acidic substances into the duodenum to add to the already acidic slurry from the stomach. There are lots of submucosal glands in the duodenum, and they secrete a very bicarbonate-rich solution. So this bicarbonate-rich solution raises the pH of that acidic slurry of a pH of 1 or 2 that's coming from the stomach. The jejunum, which is the middle part of the small intestine, is all about absorption. It has the surface area increases and the features that we described. In this histological picture on the right, you can see all of those scattered mucus cells, like the white bubbles in the epithelium. These open areas between the villi, or these finger-like projections here, is the lumen of the stomach. These areas are called intestinal crypts. And they're similar to the glands we saw in the stomach, but these crypts here have more secretory cells in them and more enteroendocrine cells. The ileum is the last place that nutrients can be absorbed by the small intestine. In the ileum, the small intestine, it's also getting the remnants of food ready for the large intestine. So chemical digestion, it's continuing to extract just the last bit of nutrients that it can. At this point, the chyme, or little Lisa's slurry, is kind of turning back into a bolus, and it's becoming less liquidy. There are more mucus cells scattered along the epithelium, right, trying to provide lubrication for the bolus and trying to buffer for the food as it enters into the large intestine. The small intestine and the large intestine are separated by the ileocecal valve. Unfortunately, when this valve opens, a little bit of the contents of the large intestine spew back into the ileum. These contents could put the ileum at risk for infection or invasion. And there are two things at the ileocecal valve that try to prevent this. One is the appendix on the large intestine side of the valve. The other are things called Peyer's patches, and they're strategically placed in the ileum just before the ileocecal valve. Peyer's patches are found in the submucosa of the ileum and just before the ileocecal valve. These patches are really similar to tonsils. They protect against pathogens, and they're part of the immune system's MALT, or the mucosa-associated lymphoid tissue. These patches are kind of like little lymph nodes that are monitoring the backwash coming from the large intestine. As we mentioned before, both of these diseases, celiac and Crohn's disease, cause inflammation of the small intestine's mucosa. This strips the small intestine of its carefully created surface area, and it reduces the amount of absorption of nutrients. There are different types of Crohn's disease. One of my relatives has jejunitis. There's ileojejunitis. It depends on which part of your small intestine is really suffering. My aunt spent a lot of time in her childhood with flare-ups and suffered many issues associated with malnutrition. She also, because this was diagnosed in the 50s, received treatments that included long courses of prednisone or corticosteroids. My aunt was on prednisone for more than 50 years. And one of the effects of that is that my aunt's skin is like tissue paper. It is very thin from the prolonged use of those corticosteroids.